Welcome to day 1 of the 60-day Cloud Security Challenge. Over the next 2 months, we are going from cloud fundamentals all the way to advanced cloud penetration testing. Today we are laying the groundwork, and I promise this is not going to be a rehash of what cloud computing is. We are going to talk about what cloud computing means for security engineers specifically. Because the mental model shift here is significant, and getting it wrong early leads to gaps that are hard to fix later. Let me start with the biggest change. Traditional security is built around physical perimeters. You have a data center, a network edge, firewalls controlling traffic flow, and inside the perimeter things are relatively trusted. Cloud dissolves all of that. Your data center is now an API endpoint. Your firewall is an IAM policy written in JSON. Your network spans multiple regions and possibly multiple providers. An attacker with valid credentials can access your resources from a coffee shop in another country, and there is no network perimeter to stop them. This is why identity has replaced network boundaries as the primary security control in cloud environments. Every API call carries authentication credentials, and those credentials determine what actions are allowed. If your IAM policies are too permissive, no amount of network security will save you. Now the shared responsibility model. You have probably seen the diagrams, IaaS, PaaS, SaaS, with different colored boxes showing who manages what. But let me make this concrete. If you are running an EC2 instance, and a Linux kernel vulnerability drops tomorrow, that is your problem. You need to patch it. But if you are running a Lambda function and the same kernel vulnerability drops, that is AWS problem. Your responsibility on Lambda is the function code and the IAM role attached to it. Here is where teams get burned. They assume moving to managed services eliminates security work. It does not. It shifts the work from patching operating systems to managing permissions, configurations, and data access policies. 215 to 315. Let me talk about something specific that has caused real breaches: the instance metadata service. Every cloud provider runs a metadata service accessible from within virtual machines. On AWS, it lives at a specific internal IP address. This service hands out temporary credentials to whatever IAM role is attached to the instance. The security problem is obvious. If your web application has a server-side request forgery vulnerability, an attacker can make your application query the metadata service and return those credentials. That is exactly what happened in the Capital One breach. A misconfigured WAF role combined with SSRF gave an attacker access to credentials that could read S3 buckets containing over 100 million customer records. AWS introduced IMDS v2 to mitigate this by requiring a put request before credentials are returned. 3:15 to 4 o'clock. Cloud audit logging is your forensic foundation. On premises, you might rely on packet captures, Windows event logs, or EDR telemetry. In the cloud, your primary evidence source is API audit logs. AWS CloudTrail, Azure Activity Log, GCP Cloud Audit Logs, they all record who did what, when, and from where. Every resource creation, every permission change, every data access request. The critical action is making sure these logs are stored in a location the attacker cannot tamper with. Best practice is a separate account or project dedicated to log storage, with write-only access from production accounts. If an attacker gains admin access to your production account, the first thing they will do is try to delete or disable logging. Cross-account log storage prevents that. Let me run through 2 real breaches to drive these points home. Capital One 2019, misconfigured WAF role plus SSRF equals stolen metadata credentials equals access to S3 buckets with customer data. The root cause was an IAM role that was too permissive. Microsoft Storm 0558 in 2023, a stolen consumer signing key allowed attackers to forge Authentication tokens for enterprise email accounts. The root cause was key management and validation failures. Neither breach involved a zero-day exploit in the traditional sense. Both were configuration and credential management failures. This is the pattern you will see repeatedly in cloud security incidents. One more thing before we wrap up. Set up billing alerts on day 1. I am not saying this because of budget management. Cloud cost anomalies are one of the fastest indicators of compromise. Cryptomining is the most common post-compromise activity in cloud environments. Attackers spin up GPU instances across every region they can access. A normal $2,000 monthly bill can hit $50,000 in hours. A billing alert that fires at an unusual hour is often faster than any security-specific detection. Treat your billing dashboard as a security monitoring tool. That is the foundation. Cloud security is about identity, configuration, and API-level visibility. Tomorrow in day 2, we are setting up an AWS account with security best practices from scratch, root account lockdown, MFA everywhere, and an organization structure that enforces least privilege at the account level. Day 3 goes deep on IAM. These first 3 days build the foundation that everything else in this challenge depends on. If you are following along, I will see you tomorrow.